Right. Hi, it's Sunday night, and finally getting around to doing the special right triangles lesson. Sorry, I couldn't find a camera before, that's why we couldn't start, but here we go. There are two types of special right triangles. There is the 30, 60, 90, and there is the 45, 45, 90. Here's how it works. The 30, 60, 90, say that this side was 1. Well, this side would be twice as big. So if this one was 1, then this one would be 2. And this one would be this one times the square root of 3. So it would be 1 times the square root of 3, which is just the square root of 3. To prove it, if this one's 1 and this one's 2, you can do 1 squared plus square root of 3 squared equals 2 squared, which is true because 1 squared is 1. Square root of 3 squared is 3, and 2 squared is 4, and 1 plus 3 equals 4. So there you have it. The second one, the 45, 45, 90, these two sides are congruent. So whatever this one is, this one will be the same, and this one will be bigger. So if this one was 1, this one would also be 1. And then this one would be either one of these two times the square root of 2. So it would be the square root of 2, because it's 1 times the square root of 2. To show it in the Pythagorean theorem, it's 1 squared plus 1 squared equals square root of 2 squared. Since 1 squared is 1, then 1 plus 1 equals the square root of 2 squared, which is 2. And 1 plus 1 equals 2. So that's how you have it. Now that's just basically the idea. So again, the 30, 60, 90, whatever this is, this one will be twice as long, and this one will be this one times the square root of 3. In the 45, 45, 90, this one and this one are congruent, and this one is either of those times the square root of 2. Alright, let's look at where they really come from. We'll start by looking at a square. If we know about a square, what we know is that all four angles are 90 degrees and all four sides are congruent. So if you were to cut a square corner to corner, kind of like cutting a sandwich, you'd be cutting this 90-degree angle into two 45-degree angles. And what you'd have is, again, these two sides being congruent. You see how that works? It looks just like what we saw before. So let's use a different number this time. Let's use 3 here. If this is 3, this also has to be 3. And so then you can do the Pythagorean theorem to find side C, and it would work like this. 3 squared plus 3 squared equals C squared. That would be 9 plus 9 equals C squared. That would be 18 equals C squared. And then you take the square root of both sides. In the 18, it'd be the square root of 9 times the square root of 2. The square root of 9 is 3. So it would be 3 square root of 2. And that would be C. So again, these two are the same. And this one is whatever those are times the square root of 2. So we're kind of getting used to this pattern now. So that's the 45, 45, 90. The second one is based on sort of the equilateral triangle formula. So let's say these were all 5, because of course that's how it works in an equilateral triangle. All sides are the same. That's what equilateral means. Each of these angles would then be 60, because of course triangles add up to 180. Well, if I cut an equilateral triangle right down the middle, then I cut this 5 in half. So then this is 5 over 2. And this is 5, and then this would be 5 square root of 3 over 2. Because it's this times the square root of 3. If you want me to prove it with the Pythagorean theorem, this is kind of an opportunity to do a little bit of extra math. So it would be like this: 5 over 2 squared plus 5 square root of 3 over 2 squared equals 5 squared. Now that looks pretty crazy for a second, but it's actually an opportunity to learn how things really work here. 5 over 2 squared would be 25 over 4. 5 square root of 3 squared would be, well, 5 squared is 25. Square root of 3 squared is 3 over 4. So it would be 25 times 3 over 4. And all of that equals, of course, 5 squared, which is 25. Well, if you notice what you get here, 25 times 3 is 75. So we'd have 25 over 4 plus 75 over 4, which equals 100 over 4, which of course equals 25. So as you can see, 25 equals 25. So therefore, yes, the Pythagorean theorem checks out here on our 30, 60, 90. To look at it another way, this is 60 degrees. This, of course, is half of 60, so this is 30, and this is 90. This has to be half of this because we cut it in half, and what's left is the Pythagorean theorem, which is whatever this is times the square root of 3. So if you just kind of memorize that, the problems get much easier. All right, so let's try some samples here. Here's a 30, 60, 90. We've got A here. We know that B will equal A times the square root of 3. So it's going to be 2 square root of 3, which is A, times the square root of 3. So what we got is 2 times the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 is 3, so 2 times 3 will be our answer. Y will be 6. If you want to find Z, that's pretty easy too, because remember, the third side, the C side, is always twice as long as this. So if this is 2 square root of 3, then this will be 4 square root of 3. And of course, X is really easy too, because it's just 90. After all, 30 plus 60 makes 90, so by the triangle sum theorem, we've got 90 there. So, solve these variables pretty quickly. Okay, now, to find the area, it's going to be base times height divided by 2. The base is 2 square root of 3, the height is 6. So 2 square root of 3 times 6 is 12 square root of 3, and 12 square root of 3 divided by 2 is 6 square root of 3. Not too bad. Again, 2 square root of 3 times 6 divided by 2. Base times height divided by 2. The perimeter, we're going to add up all three sides. Now, as you can probably tell, we have actually 3 different sides, and 2 of them are like terms, but the third one is not. So I can add these two together, and I have to add this as a separate term. So 2 square root of 3 plus 4 square root of 3 is 6 square root of 3. And the 6 cannot be added, so we get 6 plus 6 square root of 3 units for the perimeter. All right. Now we have what looks like a 45, 45, 90. If we need to prove it, well, this is 90, and these two are marked congruent, so they have to add up to 90 as well. So this must equal 45, which means this must also equal 45. That's not too hard. And clearly, if this angle and this angle are congruent, then their opposite sides must be congruent. So this really isn't a new concept to us. This is 2 square root of 2, so this has to also be 2 square root of 2. And then Z has to be either one of these times the square root of 2. So what you get is 2 square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is 2. So we end up with 2 times 2, which equals 4. So Z is 4. X, as we figured out right away, was 45, and Y was 2 square root of 2. Alright, now we need to find the area. Well, the area is going to be base times height divided by 2. So this is kind of interesting, because you have 2 square root of 2 times 2 square root of 2 divided by 2. So it's easy to be a little intimidated by that, but if you pay attention to what it says, it's not that hard. 2 square root of 2 times 2 square root of 2, well, 2 times 2 is 4, and the square root of 2 times the square root of 2 is 2, and all of that makes 8. So this becomes 8. 8 divided by 2 is 4, so the area is 4 units squared. And the perimeter will be the sum of the three sides. So we have 2 square root of 2 plus 2 square root of 2 plus 4. These are combinable like terms, so 2 square root of 2 plus 2 square root of 2 is 4 square root of 2, and that 4 is non-combinable, so it gets tacked on to the end. So what we get is 4 square root of 2 plus 4 units. And as you may notice, this time I put the square root number first. Over here I put the regular number first. Clearly there is no pattern here. Either way works, so don't worry about it. Okay, Last version will be a combination problem. So let's study this problem because it's going to have both types of special right triangles in here. This one is clearly the 30, 60, 90, and this is the 45, 45, 90. In order to prove it, well, we know this is 90, so these two have to add up to 90. This says 2x and this says 4x. So together they're 6x. And if 6x equals 90, then x has to equal 15 because 90 divided by 6 is 15. Meaning that this is a 30-degree angle because it's 2 times 15, and this is a 60-degree angle because it is 4 times 15. If this one is 3x and x is 15, then this has to be 45, and this one also has to be 45 because they're both 3 times 15. And this one's 90, which makes a lot of sense because it's a linear pair to this other 90. Alright, the only side length we know right away is this 10, but we know that in 30, 60, 90 triangles, this side, the A side, is always half of the C side. So if this one's going to be 10, then this one's going to be 10 divided by 2, or 5. And then this side is always A times the square root of 3. So this will be 5 square root of 3. This is also 5, so then this has to be 5 because A and B are always congruent in 45, 45, 90s, and C is A or B times the square root of 2. Alright, interesting, because now we have a lot of information solved here. What you may notice is that Z has to be actually the combination of these two. So Z is going to be 5 square root of 3 plus 5. X is 15, Y is 5. Okay, now to find the total area, what we really should do is find the area of this triangle and then add it to the area of this triangle. So this triangle is going to be 5 square root of 3 times 5 divided by 2. You'll get 25 square root of 3 over 2. Funny thing is, this is not a reducible number. That's what we're left with. And this one is going to be just 5 times 5 over 2, which will be 25 over 2. So as you notice, between the two, we at least have the same denominator, which makes them combinable to a degree. It can be represented as 25 square root of 3 plus 25 over 2, which is a perfectly reasonable way to represent the combined area of these two triangles. So there you have it. The perimeter will be 5 square root of 3 plus 10 plus 5 square root of 2 plus 5. The only combinable terms we have here is this 5 and this 10. So 5 plus 10 is 15, but the square root of 3 and the square root of 2 are not combinable. So what we get, we can say 15 plus 5 square root of 3 plus 5 square root of 2. 15 plus 5 square root of 3 plus 5 square root of 2, all as one uncombinable term, and that's units. Alright, beautiful little problem, lots of little stuff in there. Hopefully you understand it. Alright, rewind, enjoy, study,